more applied dimensional analysis, mass and volume. So first thing we're going to deal with is density. What's density? Well, density means it's the mass over the volume. So it's kind of the amount of stuff that takes a certain up a space. So stuff over space. So it kind of gives us, is something really dense, right? Like gold could be pretty dense, whereas other things like wood is not as dense, right? So it's kind of a way to measure them. So we can use density as a conversion factor to find an unknown mass or volume. And then what's also really important to know is 1 cubic centimeter is equal to 1 milliliter. So, right, it's just a space like that. If we were to say these are equal, so we can say this is either 1 cubic centimeters or this is 1 milliliters, but these are equal. So you can see this interchangeable with density when we measure volume, is that it's usually in either centimeters cubed or milliliters. And mass is usually measured in grams, because this is mass and it's not weight because it doesn't deal with the gravity of it. So let's go over some examples. So example 1, what is the mass in kilograms of a 453 cubic centimeter block of wood if the density is 0.823 grams per centimeters cubed? So we're looking for the mass in kilograms. So when we look at our density, we notice that it's in grams. So we're going to have to do a little bit of converting later. But first, let's go ahead and find the mass. So the first thing we're going to do is we're going to start out with the known volume. So we have 453 cubic centimeters. Next, we're going to use our conversion factor here. Density is a conversion factor. So notice that we can just leave it as is. We don't need to flip this. So this could be 0.823 grams per, say, 1 cubic centimeters. Or we can flip it and put 1 cubic centimeters on the top and 0.823 grams. It depends on how we're getting rid of our units, right? But we're going to use this one because we need the cubic centimeters on the bottom. So we have grams over 1 cubic centimeters. So what's important about this? This crosses out. That's really important. Then we're left with grams. So we can do two things. We can either keep converting, because we need to go from grams to kilograms, which we remember, right? We have 1,000 grams is equal to 1 kilogram, right? A kilogram is much larger of a unit than just a regular gram. So we need 1,000 grams to equal 1 kilogram. So now we can actually cross out these grams and we're left with kilograms, which is exactly what we want. We want the mass in kilograms. So that's it. That's our whole step. Steps to find the mass in kilograms. So let's go ahead and get our calculators out. We have 453 times 0.823. So that gets us 372.819. And let's go ahead and divide it by 1,000. So we're going to get 0.3728. So we'll just leave it at 4 decimal places here and not do the 19. So let's go ahead and put 0.3728. And this is in kilograms. Now let's do another example. Example 2. An experimental automobile has a 100-liter fuel tank filled with ethanol. How many pounds does the fuel add to the mass of the car? So let's kind of think of this through. We have the density of ethanol here, which is given to us as 0.789 grams per milliliter. Notice they didn't use cubic centimeters, they used milliliters. Then we also need to know this conversion. 1 kilogram is equal to 2.205 pounds. Because we noticed that grams per milliliter, right, is in the metric system, and they want it in the US customary unit of pounds. So we're going to have to do a little bit of converting here. So we know we have a 100-liter tank. Now, notice that if we need to find the mass, we could use the density. But notice how the density is in milliliters. So we need to go from liters to milliliters first. So we're going to use a conversion factor to liters to milliliters, right? So we know 1 liter is equal to 1,000 milliliters. Then we need to go all the way from milliliters to just grams. So we're going to use the density. We'll just say density. This is kind of our crosswalk. And then we go from grams to pounds. So we're going to use but notice that this is kilograms to pounds. So we're actually going to have to go grams to first kilograms to then pounds. So that's kind of our steps if you need to think about it. So let's go ahead and work this out. We know we have 100 liters. Let's go ahead and convert this because we need to go from liters to milliliters. And the reason why we know this is because density is in milliliters, not liters. So let's go ahead and do that. So 1 liter is equal to 1,000 milliliters. Right, we can get that from our conversion chart, or we can just remember, right, we need 1,000 milliliters to equal a whole liter. Let's keep working. So now we need to get rid of milliliters. Well, if we need to go from milliliters to eventually grams, let's just go ahead and use our conversion factor of density, right? If we use this, we get rid of milliliters, just like that. We get rid of liters here. So now we have grams. So we're really close to being done. Right, we got from a volume. Now we're not getting into our mass by using density. Density is a really cool thing we can use here. So let's go ahead and use a different thing to know that we're now at mass. So we know 1,000 grams is equal to 1 kilogram. Now, we're not done because we don't want in kilograms. We need it in pounds. So let's go ahead and use this conversion. We're going to put the kilograms on the bottom, and then on the top we're going to put 2.205 pounds. Now let's go ahead and cross out all the units. So can we get rid of grams? We got rid of kilograms, and then we're left with pounds. So we just went from a 100-liter fuel tank, used density, but we had to use a conversion from liters to milliliters, and then we had to use grams to kilograms conversion, and then we had to use our metric to US customary conversion factor to get to pounds, but we didn't. So now all we have to do is just pull up a calculator. So let's go 100 times 1,000 times 0.789. Let's put this over here. Then we go ahead and we can divide by 1,000 because that's what that is. And then we're going to go times 2.205. And what do we get? We get 173.97. And what's this in? This is in pounds, which is very important. So remember, let the units guide us. So now let's do one more example. Example 3. A drop of gasoline has a mass of 22 milligrams and has a density of 0.754 grams per cubic centimeters. What's the volume in cubic centimeters? So let's go ahead and do this conversion. So let's start out with the starting number of 22 milligrams. We're always going to start out with our mass or volume and then use density as a conversion next. So if we have 22 milligrams, Now we need to get to cubic centimeters. So when we look at density, we have cubic centimeters, so that's great. The only thing is that this is in grams and this is milligrams. So we just need to do a simple conversion. So we know 1,000 milligrams is equal to 1 gram. Next, we need to get rid of grams. So let's go ahead and use density. But this is where it's interesting. We're going to actually flip this onto the bottom. And why we do this is because we need to get rid of grams. So in order to get rid of grams, we put on the bottom the number and put on top 1 centimeters cubed. This allows us to get rid of grams, and then we can get rid of milligrams, and we're left with cubic centimeters, which is exactly what we want. So now we just get our calculators out and go ahead and do this. 22 divided by 1,000, and then we're going to divide it by 0.754. So we get 0.029. So we'll just go to the third decimal here. And this is in cubic centimeters. So that would be the volume of the gasoline if the mass was 22 milligrams.